So, Carnot, who are we? What do we do? So, we are looking to tackle the trillion-dollar problem of decarbonising energy industry and transport with applications like the marine sector, heavy-duty vehicles, off-grid power, and these sectors between them account for about 13% of global emissions. And despite the scale of the problem, there currently exists no practical method to decarbonise these applications. So, what options do they have? Well, first and foremost, of course, they've got the conventional engine, which has been a loyal and effective workhorse over the years. It's a high power density, brilliant range, very durable, and basically provides a pretty effective, cost-efficient way of providing power. Only problem, of course, it generates emissions, which we don't like anymore. And yes, it's inherently inefficient. Secondly, we have the battery. Now, we know batteries are absolutely brilliant when it comes to short range, light load applications. When you're scaling it up to the sort of the ranges we're trying to get to and the high load requirements, the scale of the batteries, the weight of the batteries becomes impractical and not really a goer. Fuel cells share a lot of these challenges as well, but they have the added complication of also being inextricably linked to the future, the green hydrogen industry, which is, as we know, is one thing we're talking a lot about accelerating, but is nonetheless a bit of a challenge. So where do we go? Well, our conjecture is that what we really want is we want a highly efficient and clean engine. And that's basically what we are doing. So we are developing the world's most efficient, fuel-agnostic, low-to-net zero powertrain, which I appreciate is a bit of a mouthful, so we'll go through that a bit. But at the core of our technology is our uncooled engine. So about 30% of the typical energy generated in an engine is immediately lost to cooling. You've effectively got to suck that heat out of the engine to maintain the integrity of the metallic components. Using innovative engine design and technical ceramics, we are able to completely eliminate all need for a cooling system, and we can now put this energy back to work, which is one of the key elements in how we can achieve our leading and frankly unparalleled 70% thermal efficiency. Whilst hydrogen, missing a slide here, but whatever, whilst hydrogen is the focus where we want to end up, this technology is completely fuel agnostic. So we can work with e-fuels, we can work with biofuels, and we're also doing some pretty exciting things with ammonia blends, which we'll touch on later. But this flexibility allows us to put in place some quite innovative roadmaps for our clients to get to net zero. So who are our partners? Well, two of our current favourites. We've got Oz Minerals, who are a big Australian mining outfit, and Carisbrooke Shipping. Now, Carisbrooke's one where we've recently done a project with them looking at replacing their existing auxiliary engines using a quite intelligent hydrogen ammonia blend, containerized solution mounted on the bow. Now, two big takeaways from this. First one, turns out we were cheaper than a diesel equivalent already, even with current date hydrogen costs. And secondly, and probably arguably more excitingly for us, is we are generating almost negligible NOx emissions. Always been a problem with hydrogen powertrains. And yeah, we're well below California regulations, so the most stringent environmental standard for this stuff, but also, 0.04 grams per kilowatt is less than 10% of what you get from the most advanced diesel engine today. So, we knew we were going to get to negligible NOx emissions, we just didn't know quite yet. So that's pretty exciting. So, we're making net zero affordable and practical now, which is really rather jazzy. So how are we going to do that? Well, we want to be in production by 2026, and we'll be working with the existing value chain to make that happen, so existing engine manufacturers, but also working with OEMs. So we want to integrate our powertrains into their solutions. So we'll be starting with gensets, because generator manufacturers, because that's an easier regulatory environment for us to work in, but we'll move on to prime propulsion and stuff like that later. In the short term, we need to be delivering our field trials by 2024. So we've got our two we touched upon earlier, Carisbrooke and Oz. We've got capacity, we think, to do about 5. Key part of this, field trials is your primary step to get to certification for your engine. And the hardest part of getting certified is getting the field trials. Well, we've got the platforms. We've got the platforms to go and do it with our agreed partners. We've got the team, we've got the technology, and so right on cue, the last thing we need is the money. And so we're looking to raise our Series A at the moment, and yeah, we're in discussions already with partners, but we're looking for partners who really understand the impact and the decarbonising journey we want to go on. So Yeah, some of our existing partners. We're also in University of Oxford spin out, which is always quite nice. That's me. Thank you very much.
Excellent. Thank you.